9.4 special right triangles. This is a very, very important section um, that you'll use over and over again in higher level mathematics, especially trigonometry classes and advanced math and calculus. We use this a lot, so it's nice to memorize these two formulas that we're going to see today. But before we get to those formulas, we're going to do this little warm-up. We're going to solve for x, y, and z, and as we're doing this, we're going to look for a pattern. So to find x in a right triangle, we can use Pythagorean theorem. 1 squared plus 1 squared equals x squared. Well, 1 squared is 1, so we end up with 2 equals x squared. And if we want to know what x is, we take the square root. Now the next one, 2 squared plus 2 squared equals y squared. Well, 2 squared is 4. 4 plus 4 is 8. And to find y, we have to take the square root of 8. Well, simplifying the square root of 8, that is like the square root of 4 times the square root of 2. Square root of 4 is 2. And now our last problem here, when we use 3 squared plus 3 squared, that's going to equal z squared. We get 9. 9 plus 9 is 18. That's going to equal z squared. Well, we have to take the square root to get z by itself. Once again, we can simplify 18 as the square root of 9 times the square root of 2. And the square root of 9 is 3 times the square root of 2. So hopefully you'll see the pattern. You could think of this as 1 times the square root of 2, 2 times the square root of 2, 3 times the square root of 3, or 2. And we can generalize this pattern into this first theorem about isosceles right triangles. Remember, an isosceles right triangle is where the side lengths are the same. It has to have two sides to be the same for an isosceles. If this is a right angle, that means these have to be 45-degree angles. So oftentimes an isosceles right triangle we're going to call a 45, 45, 90 right triangle. If these legs are x, the hypotenuse has a length of x times the square root of 2. And that's the first theorem. Our second theorem, you could do the same thing that we did in that warm-up with the 45, 45, 90 triangle. Half an equilateral triangle, I like to think of it like this. An equilateral triangle, if you remember, all the angles are 60 degrees. Well, if I split this in half, that's going to make this a 30-degree angle, and this is still going to be a 60-degree angle. So we call this a 30, 60, 90 right triangle. And now if this side length is x, that means this side length over here would have been x. So this whole length is 2x, which means this whole length is 2x. So if the short leg is x, the hypotenuse is 2x, and using the Pythagorean theorem on that, you get that this leg is x times the square root of 3. So this one's square root of 2, the 30, 60, 90 triangle is the square root of 3. Okay? We can use that to quickly find side lengths, and it'll be simplified and it'll be exact. So in this case, we'll use that first theorem where we take this leg and multiply it by the square root of 2. So x equals 5 times the square root of 2. This problem, we're going to say, well, this side length times the square root of 2 is 12. So I'm going to just kind of almost write out a equation, I know I'm multiplying it by the square root of 2, I'm getting 12. And now notice there's no radical on this side. So I think to myself, to make there not to be a radical, I need a square root of 2 as part of my x. Because I know the square root of 2 times the square root of 2 is 2. Right? Square root of 2 times the square root of 2 is 2. So 2 times what is 12? 6. So 6 times the square root of 2 times the square root of 2 equals 12. So x in this problem is 6 times the square root of 2. This problem is going to be a little tricky. We're given the long leg. Remember, if I drew the equilateral triangle out, it's going to look like this. So I first want to find my short leg, and I know this side's double it. That's the easy one. To find f, I'm thinking, well, f times the square root of 3 has to equal 18. So I know since there's no radical over here, f has to have a radical in it. Okay, so square root of 3, I have to multiply that by a square root of 3 in order for the radical to disappear. Square root of 3 times the square root of 3 is 3. So I ask myself, 3 times what is 18? 3 times a 6 is 18. So we know f equals 6 times the square root of 3. Now g, so if f is 6 times the square root of 3, this length, the side length of the equilateral triangle is twice that long. So g is going to be 2 times that, or 12 times the square root of 3. Ramp is used to unload trucks. How high is the end of a 50-foot ramp? So the ramp is 50 feet when it is tipped by a 30-degree angle. So we're assuming that this is a 30-degree angle here. We want to know how high this side gets up. So if this is a 30-degree angle, we have a 30, 60, 90 triangle. And I know that if this is 50 feet, remember this is kind of half, this picture's not drawn to scale by any means, but this is like the side of that equilateral triangle, right? If I extend that down, here's the other side of that equilateral triangle. So if this is 50 feet, this has to be half of that, or 25 feet. Okay, that's how high that would be. So obviously this is not a 30-degree angle, but it makes for a good problem. Might as well do one more here. The roof of a doghouse is shaped like an equilateral triangle with a height of 3 feet. Okay, so if this is 3 feet, estimate the area of the cross section of the roof. They're asking us to find the cross section is this triangle. So in order to find the area of this triangle, we need to find this side length. So if this is a equilateral triangle and we split it in half, we're going to end up with a 30, 60, 90 right triangle, and we know this is 3. Okay, to find this side length, the relationship between this side and the long leg of the equilateral triangle is going to be that multiple of square root of 3. some number times the square root of 3, we want that to equal 3. Notice no radical here, so how do I get rid of the square root of 3? I know I have to have a square root of 3 times the square root of 3 equal 3. So this is the square root of 3. That means this total length is going to be 2 times the square root of 3. And I can use that to find the area of the triangle by saying 1/2 the base, 2 times the square root of 3, times the height of 3, is going to give me my answer, my area of 1/2 times 2, that cancels. So square root of 3 times 3. That would be kind of an exact answer. They say estimate it, so I think they want us to round it. So I'll take out the calculator and say, figure out what the square root of 3 is first. And then I'm going to multiply it by 3. And that is about 5 point, I didn't check the decimal point, say 5.2 feet squared. Okay, it's an area, square feet. Okay, no, that goes pretty fast. It's important to ask questions on this stuff. I'm sure you'll have them. Hopefully, with a couple questions, we can get going on this homework assignment in class. Talk to you then.